coal resources. Objectives. After attending this lesson, the user should be able to understand the importance and properties of coal, their origin and formation of coal, their classification and worldwide distribution of coal, including Indian coal and lignite. Introduction. Planet Earth has thousands of mineral resources. Minerals are the backbone of civilization. The available mineral resources of any country can propel the economic growth. Minerals have shaped our civilization from the Stone Age to the modern information age. Among the naturally occurring mineral resources, we do have mineral fuels, including oil and coal resources. Energy is a key input to the economic growth and for the improved quality of life. Coal has been used for several hundred years as a fuel. Currently, coal accounts for about 50% of the commercial energy use and about 24% of total primary energy needs of the country. About 70% of the power generated is from coal and lignite. Coal as a fuel. The word coal is derived from the Saxon word coal, from the Sanskrit term kala, and from the English term coal. Coal is considered as a rock, as it is a natural solid substance forming one of the units of the Earth's crust. It cannot be strictly considered as a mineral, as it is not a homogeneous substance. Coal is not of inorganic origin. It does not have a definite chemical composition. In trade and industry, coal is regarded as a mineral. Coal is one of the chief fossil fuels or mineral fuels. It is an important source of heat and energy. Coal may be defined as vegetal matter that has been subjected to a variety of geological processes and has thereby undergone remarkable changes in physical properties as well as in chemical composition. The changes mainly involve the darkening of color, increase in hardness and compactness, loss of moisture and volatiles such as carbon dioxide, hydrogen and oxygen, and an increase in carbon content. The scientific definition of coal is given by E.A.N. Arbia that coal is a solid stratified rock composed mainly of hydrocarbons and capable of being used as a fuel to supply heat or light or both. Varieties and ranks of coals. Initially, there were two general varieties of coal as humic coal and saprogenic coal. The humic coals are the most important and are mainly formed from the remains of the wood and bark of the original plants. The saprogenic coals are formed from non-woody matter as leaves, spores, enrich of plants, and also from organic oozes, algae, fungi. These coals contain less carbon than normal coal, and they are massive, and on distillation they give petroleum. Example, cannel coal. The saprogenic coals are considered to be transitory stage between true coal and petroleum. Sometimes they are termed sapropellites, as they are originated from the sapropellium. Coal in Earth's geological history. Coal deposits are found in sedimentary sequences of Tertiary and Gondwana periods. Scientists refer to them as Tertiary coals and Gondwana coals. Modern classification of coal. The following varieties of coal were recognized so far based on the extent to which the physical and chemical changes have proceeded in the transformation of vegetal matter into coals. Peat, lignite, sub-bituminous coal, bituminous coal, semi-anthracite, anthracite. Peat represents the first stage in the coal formation. It may be defined as a mass of vegetal matter that has undergone a varying degree of disintegration and decomposition. It is a compact, fibrous and porous substance, varying from light brown to dark brown in color, in which the remains of original vegetal matter can be seen. It contains a high percentage of moisture, up to 85%, 10.4% of volatile matter, 4.6% of fixed carbon, and has a calorific value of about 3,500 British thermal units. Peat is not an economical fuel. It is mostly used as a fertilizer or in the manufacture of fertilizer because of its rich nitrogen content, up to 2%. Important deposits of peat are found in England, Scotland, Virginia, etc. In India, peat beds are reported from Palani and Nilgiri hills of Tamil Nadu and Kashmir. Submerged beds of peat are recorded from both sides of Hooghly River in Kolkata. Lignite. It is also called as brown coal because of its characteristic brown color. It is generally woody in nature. It contains a high proportion of moisture, 25 to 45%. It burns with a long brown flame and it has a low heating power. Lignite is used for distillation, combustion, briquetting and gasification or manufacture of gas. Some lignites are hard compact, as in the case of Neyveli lignite. Lignites are utilized for generating thermal power and also in the manufacture of fertilizers. The calorific value ranges from 11,000 to 12,500 British thermal units per pound. Sub-bituminous coal. It is a dull black coal which is intermediate in grade between lignite and bituminous coal. It is practically free of woody matter or plant materials. Some of lower Gondwana coals and of Eocene coals are of this type. Bituminous coal. This term is derived from the word bitumen, though it does not contain bitumens. It is a common commercial rank coal. It is dense, compact and black in color and free from vegetable material. Usually, it is laminated with alternate dull and bright bands. It burns with a smoky yellow flame similar to that of bitumen. It exhibits dull to resinous luster. It breaks along vertical joints called cleats, giving rise to rectangular or cubical blocks. Bituminous coals are considered as all-purpose coals, and because of its excellent heating quality, it is most extensively used as fossil fuel in the world. It is used for steam raising and heating purposes. Bituminous coals are also used for the production of gas and coke. Bituminous coals are classified into high volatile and low volatile coals. Semi-anthracite. It is harder than bituminous coal. It burns with a short yellow flame at first and then with a blue flame. Anthracite. It is a hard coal with jet black or iron black color and semi-metallic luster. It does not soil the finger and breaks with conchoid's fracture. It burns with short blue flames without smoke. Hardness varies from 2.75 to 3 and specific gravity from 1.27 to 1.7 grams per cubic centimeter. It has a high heating value. It is used exclusively for domestic heating purposes wherever available. It has no coking property and it is not as common as the bituminous coals. Chemical composition of coal. Chemically, coal consists of a mixture of complex organic compounds along with small amounts of inorganic mineral matter and moisture. Carbon, hydrogen, and oxygen are the principal constituents of coal, along with small amounts of nitrogen and sulfur. The proportion of these elements is as shown in Table 1 from wood to anthracite, according to Clark. It is seen from the table that there is a steady increase of carbon and a corresponding decrease in oxygen from wood to anthracite. Hydrogen also decreases very gradually and nitrogen content remains constant. The chemical composition of coal is determined either by the proximate analysis or by the ultimate analysis. The proximate analysis consists of determination of the following. Moisture content. Presence of moisture in coal may be coming due to absorbed water on the external surface of coal or in pores of coal, and it is called free water. It is also present as dissolved water or as water resulting from the decomposition of organic compounds, and it is termed as inherent or hygroscopic moisture. The inherent moisture can be roughly taken as a measure of the rank of coal. The tertiary coals have relatively high moisture content than the Gondwana coals. Volatile matter. The volatile matter obtained during the analysis of coal consists of combustible gases, hydrogen, carbon monoxide, methane, and hydrocarbon. It also includes tar vapors and incombustible gases like carbon dioxide and water vapor. Coals with volatile matter less than 17% or more than 40% are not good coking coals. Therefore, the volatile matter controls the coking property and determines the rank of coal. Ash content. The amount of ash content in coal varies widely with reference to different coals. It is below 2% or it may be high as 20 to 30%. Assam coals contain 8% of ash. Gondwana coals contain up to 10% of ash content. Coals that have high ash content are generally regarded as low-grade coals. Fixed carbon. The carbon that has not combined with any other element of coal is referred to as fixed carbon. The amount of fixed carbon increases with the rank of coal and it is highest in anthracite. Calorific values. Calorific value is also known as the heat-raising capacity or value of coal. It can be expressed in terms of calories in the metric system or in terms of British thermal units, according to the English system. A calorie, a unit of heat, is the heat required to raise the temperature of 1 kg of water from 15 to 16 degrees Celsius. British thermal unit is the heat required to raise the temperature of 1 pound of water from 62 degree Fahrenheit to 63 degree Fahrenheit, or British thermal unit equals 0.252 calories. Ultimate analysis of coal. It refers to the estimation of the proportion of ash, carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. The high percent of oxygen is very undesirable because it reduces the heating value and affects the coking property of coal. Sulfur is present in all coals and it occurs as organic phosphorus representing the constituent of the original plants, or it may be present as the inorganic calcium phosphate derived from the intrusive magma. In India, the coalfields of Damodar Valley, phosphorus is derived mostly from highly phosphatic mica lamprophyre dikes and silts. Table 2 shows the average chemical composition of various ranks of coal after Moore. It is seen that in the series of humic coals from lignite to anthracite, both moisture content and volatile matter decreases progressively, and fixed carbon will be increased from lignite to anthracite. Peat and lignite are low-rank coals, and bituminous and anthracite are high-rank coals. Visible components of coal. Coal is not homogeneous throughout its mass, but it is composed of a number of bands or layers. There are two types of bands as bright bands and dull bands. In-depth examination shows that each of these bands show the presence of two distinct components which are distinguished by their physical characters. The notable bands of the coals are vitrain, clarion, durian, fusane. Vitrain is the principal bright component of coal having a jet black color with a brilliant and glassy surface. It occurs in thin bands or laminae. It breaks with conchoidal fracture. It shows vitreous luster. Clarion. It is also a bright component of coal, but it is less brighter than vitrain. It occurs as bands of variable thickness arranged parallel to bedding plane. It exhibits silky luster and a smooth striated surface when broken. Durian. It is the dull component of coal with a dull greyish black color and occurs as thick bands. It is hard and breaks with irregular and rough lusterless surface. Fusane. It is also called mineral charcoal and it is the soft black powdery component of coal. It occurs as patches or flat wedges. This is very friable material and charcoal. Periods of coal formation. As mentioned earlier, there are two or three principal periods of coal formation in the Earth's history. The first and most important period of coal formation was during Carboniferous to Permian times. The coal forming processes have first started in the northwestern part of the world during Carboniferous period and gradually proceeded southeastern, so that the coal seams of northern hemisphere, particularly North America and Europe, are of Carboniferous age, and coal seams of Siberia, Eastern Asia, India and Australia are of Permian age. The major coal fields of the world, characterized by high-rank coals, belong to the Carboniferous and Permian periods. The second geological period of coal formation was during Upper Cretaceous to Miocene times, found in Italy, Austria, Hungary, Japan, Indonesia and India. They are commonly referred to as tertiary coals. All lignite deposits were formed in this period. The third geological period, which is a less important period of coal formation, is Quaternary or post-tertiary times. All known peat deposits of the world were formed during this time. The major coal fields of the world have originated either in swamps or in brackish or freshwater basins, starting with abundant plant material which might have drifted into these basins or grew in situ in swamps. Stages in coal formation. The transformation of plant debris to coal occurs mainly in two successive stages as biochemical stage and geochemical stage. Biochemical stage or peat forming stage is called humification process. The changes brought about by the activity of bacteria and other microorganisms in the plant debris during this process are due to decay and decomposition of the chemical substances such as the lignins, celluloses, proteins, resins, etc., which were originally present in plants. The ultimate producers of such decay are some humic substances, and the result is the transformation of the vegetal debris into a porous, fibrous, and friable mass called the peat. This stage is the most important stage because it gives the basic material, that is, peat, which is subsequently transformed into different types of coal. Geochemical stage or transformation of peat into higher rank coals. This is called coalification process. The peat which is formed by humification process is converted into lignite and then to bituminous coal and finally into anthracite. All these happened under the influence of the conditions like temperature and pressure prevailing at depths in the Earth's crust as well as due to various geological factors. This process is called coalification process. The series peat, lignite, bituminous, anthracite is referred to as coalification series. Origin of coal. Though all varieties of coal are originated from vegetable matter, there is a wide divergence of opinions regarding the mode of accumulation of these plant remains in the water basins to give rise to coal seams. So far, two theories have been put forward to explain the origin of coal seams. They are Insitu theory and drift theory. In-situ theory. The in-situ theory suggests an in-situ origin of the coal seams, which means that the vegetal grew at the same place where we now find the coal seams, and it is said to be autochthonous in origin. Evidence in support of in-situ theory. There are large accumulations of vegetal matter forming in swamps at the present day. Some of them gave rise to coal seams. The purity of coal seams and uniformity in composition indicates that the deposition of the vegetal matter in still waters and from nearly the same source material. The numerous tree trunks were found with their roots firmly fixed in the underlying clays that lie beneath the coal seams. These clays represent the original soils on which the vegetation grew. The underlying clays are generally poor in alkalites and oxides, and these materials have been extracted and utilized by plants. Drift theory. According to this theory, the vegetal debris have been transported by water from their original site of growth to the present site of coal seams. This is said to be allochthonous in origin. Evidence in support of drift theory. Large quantities of tree trunks are being transported downstream by present-day rivers, particularly in region of forests. Beds of peat have been found in the process of formation at the deltas of some rivers at the present day. Example, delta of Ganga. The presence of marine fossils. The rocks associated with coal are distinctly sedimentary, and coal seams themselves behave like sedimentary beds. Tree trunks have been found with their tops headed downwards. Absence of clays and coal seams lie directly on sandstones, shales, or conglomerates. It is now generally accepted that coal seams of Western Europe are formed by in situ, whereas those of India have been formed by drift. Distribution of coals in India. The coal deposits of India belong to two principal geological periods. The greatest period of coal formations in the Permian. The important coal-bearing formations are together known as Damuda group of Lower Gondwana system, sequence. The coals were derived mainly from the Glossopteris flora, which flourished in the vast ancient continent of Gondwana land. Coal measures of Australia, South Africa and South America were also derived from this flora. Tertiary coals of Eocene to Miocene age in Assam, Himalaya, Lignite hills of Darjeeling district in West Bengal, Tamil Nadu, Pondicherry, Kerala, Rajasthan and Uttar Pradesh, and peat deposits of Tamil Nadu, Jammu and Kashmir of younger tertiary or quaternary age. In Kashmir, sub-anthracites of tertiary age were also reported. In other parts of India, as in Kutch and Assam, coal seams associated with rocks of Mesozoic era, Jurassic, Cretaceous, have been found. Gondwana sequence system. As the Gondwana sequence is the main source of coal in India, a brief of the geological history is given here. The name Gondwana sequence refers to a very thick group, 6,000 to 7,000 meters, of distinct freshwater sedimentary rocks of lacustrine, fluviatile, or estuarine origin and ranging in age from upper Carboniferous to lower Cretaceous periods. All the coal seams in India are interbedded with usually the sandstones and shales of freshwater origin. The structure of the sedimentary basins in which coal deposits lie indicate that they were lake basins which occupy rift valleys or faulted valleys. Coal fields of India. Coal fields of West Bengal. Raniganj coalfield. This coalfield is named after the town of Raniganj, which is the mining center. Raniganj coalfield is situated mainly in West Bengal and partly in Bihar, and it is about 185 kilometers northwest of Kolkata. This coalfield is about 1,554 square kilometers in area and is one of the largest coalfields of India. The Gondwana formations in this coalfield are extended over an area of 1,000 square kilometers. The estimated total reserves in situ of coal in the Raniganj field, according to the Committee on Assessment of Reserves of the Coal Council of India, are as follows. The proved reserves of quarryable coal, 376 million tons. Indicated reserves of quarryable coal, 44.4 million tons. Inferred reserves of quarryable coal, 48.3 million tons. Coal fields of Jharkhand. About one-third of the estimated coal reserves are distributed in the coal fields of Jharkhand and Bihar. Jharkhand is one of the leading producers of mineral wealth in the country. The total reserves of the coal in Jharkhand is of the order of 69,128 million tons, which spread over Jharia, Bokaro, Rajmahal, Hazaribagh and Chhatra areas of prime coking coal in the country. The availability of prime coking coal in the country is quite meager. The state of Jharkhand is endowed with 72.2 billion tons of coal of all categories. This is distributed in 12 major coal fields. Jharkhand is the only state which is having prime coking coal, which, with or without washing, can be directly fed to coke oven for making metallurgical coke. Jharia coal field. It is the most important productive of the Indian coal fields and is situated in the heart of the Damodar Valley, mainly along the north of the river in the Dhanbad district of Jharkhand. This coal field is named after the chief mining center Jharia, and it is situated about 260 kilometers northwest of Kolkata. It is covering an area of about 450 square kilometers and extending for a maximum of about 38 kilometers east-west and 19 kilometers north-south. The lower Gondwana rocks are very well developed in this field. The coal seams of the Jharia coal field exhibit a characteristic banding of alternate bright and dull layers of coaly matter. The coal seams are superior, which is known as selected grade coal. Bokaro coal field. This coal field contains two parts: the East Bokaro coal field area of 207 square kilometers and West Bokaro coal field area of 154 square kilometers. All the formation of the lower Gondwana system from Talcher to Panche series occur in these fields. Usually, the coals are of coking varieties. In West Bokaro coalfield, about 13 coal deposits occur up to a depth of 609 meters in this field. The coals are high in ash content, low in moisture content, and coking varieties. The Bokaro coalfield is situated in the Hazaribagh district and is the second largest coalfield in Jharkhand state, and it is named after Bokaro River. Ramgarh coalfield. This is a small coalfield occupying an area of 98 square kilometers in Barkars of Jharkhand state. About 20 coal seams are reported from this field. The coals in Ramgarh basin are of high coking variety. Coalfields of Chhattisgarh. The state of Chhattisgarh has 16% of the total coal deposits of India. 44,483 million tons of coal has been estimated in 12 coalfields of the state located in Rajgarh, Surguja, Korea and Korba districts. The state ranks second in coal production by contributing over 18% to the total national production. Most of the coal deposits are of power grade coal. NTPC and CSEB in Korba are the major producers of thermal power, and a new plant of NTPC has been started in Sipat, Bilaspur. Potential for more power generation units exist in the state. Southeastern coalfields, also called as SECL, at Korba of Chhattisgarh, is an excellent base from where the mining sector of the state has received major impetus. Since the reserves of tin, iron, dolomite, and other similar elements are spread over the huge geographical space of Chhattisgarh, hence it is but natural that mining and production costs are quite low, which in turn brings greater returns economically. North Chhattisgarh coalfields. Following are the major coalfields of North Chhattisgarh: Tatapani Ramkola coalfield, Jhilimili coalfield, Sonhat coalfield, Bishrampur coalfield. South Chhattisgarh coalfields: Hasdo Rampur, Surguja coalfield, Korba coalfield, Mand Raighar coalfield. Coalfields of Orissa. Out of 57 Gondwana and 14 tertiary coalfields for the National Inventory of Coal, Orissa state has only 2 coalfields. Yet, its share in the reserve is so far established in the country amounts to 24.78% or 58.01 British thermal units. In terms of spatial spread of prognostical coal-bearing area, the coalfields of the state of Orissa have about 7.6% area, 2,723 square kilometers. This goes to illustrate the high ratio of coal to non-coal strata in the 2 hitherto known coal-bearing basins, that is, River Coalfield and Talcher Coalfield. As a sequel to which these coalfields have an added advantage of being accorded most favored coalfield status by the nature as far as quarryable potentiality is concerned. Coalfields of Bihar. Karanapura coal field. This is another major coal field of the upper Damodar valley, including two separate areas of Gondwana rocks, such as northern area of about 1,230 square kilometers and known as North Karanapura coal field, and the southern area of about 195 square kilometers called the South Karanapura coal field in the Bihar state. The total area of this coal field is 1,424 square kilometers. There are two regions of coal occurrence as Northern Karanapura coal field, South Karanapura coal field. Coal field of Madhya Pradesh. In Madhya Pradesh, the most important coal fields are Singrauli coal field. Singrauli coal field. This coal field is situated south of the Son River and occupies an area of 2,300 square kilometers in Madhya Pradesh. This field contains 140 to 160 meters thick coal seam known as Jhingurd seam, which is the second thickest seam in the world, lies mainly in the Sidhi district of Madhya Pradesh with a small area of 80 square kilometers extending into Mirzapur district of Uttar Pradesh. The estimated reserves of coal deposits of the field are of the order of 10,851 million tons. Coal fields of Andhra Pradesh. Pranhita, Godavari Valley. The coal-bearing rocks of this valley extend over an area of 9,000 square kilometers. The lower Gondwana rock, comprising of Talcheers 61 meters, Barkers 610 meters, and Kamti beds 45 meters, are well developed. The Talcheer lie unconformity over the Vindhyans, limestones and shales, which lie on crystalline Archeans. The Kamti beds sandstones are well exposed over the most part of this region, and barkers are few, which indicate that barkers might have eroded before the deposition of Kamti beds. The barkers occupy parts of Adilabad, East Godavari, Karimnagar, Khammam, Nizamabad, Warangal, and West Godavari districts. Of all these areas, the coal mining is confined to Singareni, Tandur, and Godavari area. Singareni coalfield, Yellandu. This coalfield forms an outlier of lower Gondwana rocks, occupying an area of 5,020 square kilometers, and it lies within the Khammamet or Khammam district. This coalfield is in the form of a long, narrow strike with a length of 22.5 kilometers and 3.2 to 5 meters width, and it is the most important coal-producing field in the Godavari Valley. The coal seams occur in the northern part near Yellanlapad, which is also 185 kilometers east of Hyderabad. About 7 coal seams are recognized in this coal field, of which the bottom coal seam is known as King Seam, which varies in thickness from 1.83 to 2.1 meters. The coal is of excellent quality of non-coking variety. Another coal seam which occurs above the King Seam is referred to as Thick Seam, which varies in thickness from 9.7 to 30.4 meters. This thick seam was also named as the Queen Seam. Lignite deposit of India. Important deposits of lignite in India are found in Tamil Nadu, Pondicherry, Rajasthan, Kerala, Manipur, Nagaland, Tripura, and Uttar Pradesh. The lignite deposits reserves in India 1983 were estimated as 2,906 million tons, of which 2,590 million tons are reported from Neyveli lignite field in the South Arcot district of Tamil Nadu. Therefore, of all the lignite occurrences, the Neyveli lignite field is the most important. Neyveli lignite field, tertiary coal seams. This lignite field is centered around the Neyveli station, and it is 43 kilometers west of Kadalur Part and about 241 kilometers from Chennai. The lignite deposits in Neyveli occur in a sequence of clays and Kadalur sandstones of Miocene age. Lignite occurs as a regular seam with a thickness varying from 12 to 24 meters in the main field. No outcrops of lignite were noticed, but only in drill holes the lignite was encountered at a depth of 43 meters. At present, in the main quarry, the lignite is taken out from a depth of 54.86 meters below the surface. World coal and lignite industry. Lignite is not traded to any significant extent in world markets because of its relatively low heat content and other problems related to transport and storage. World coal and lignite consumption is projected to be around 6.8 billion tons in 2020. Coal use in developing Asia alone is projected to increase by 1.8 billion tons. China and India put together are projected to account for 29% of the increase in energy consumption. India is expected to add over 65,000 megawatts by 2020 based on coal and lignite. World coal reserves. Coal is the most abundant amongst the fossil fuels. The latest estimated worldwide coal reserves are given below in table number 3. Indian coal resources. The coal resources of India are available in sedimentary rocks of old Gondwana formations of peninsular India and the younger tertiary formations of northern and northeastern hilly region. The total coal resource in India stands at 242 billion tons. State-wise resources of Indian coal in million tons are shown in table number 4. Indian lignite resources. State-wise and category-wise lignite reserves are summarized below in million tons in table number 5. Conclusions. Coal is one of the chief fossil fuels or mineral fuels. It is an important source of heat and energy. Coal deposits are found in sedimentary sequences of tertiary and Gondwana periods. Coal is not homogeneous throughout its mass, but it is composed of a number of bands or layers. Though all varieties of coal are originated from vegetable matter, there is a wide divergence of opinions regarding the mode of accumulation of these plant remains in the water basins to give rise to coal seams. All the coal seams in India are interbedded with usually the sandstones and shales of freshwater origin.